Hello everyone. So for this video, I will go over your summer assignment review, the multiple choices one. So let's start with the first part, which is your atomic theory and models of the atom. So first question, consider the following selected postulates of Dalton's atomic theory. And you have the four statements there. Now, which ones, and those belong to Dalton. Now, which ones of those are the one that we still consider valid and which one we no longer consider valid? Well, in order to be able to answer, obviously you have to know the four postulates. And here actually they don't show the whole idea of Dalton. So what they are showing here, what they are focusing here basically, is that Dalton believes that the atom is a solid sphere, and you know that. So remember all those scientists, right? So the scientists are the ones that you are supposed to know are the first one, yes, is Dalton, right? So Dalton's idea of the atom is that it's a solid sphere. So he doesn't know that there are stuff inside, so he just believes that this is the sphere, this is the atom. Also, he has an understanding, obviously, of the periodic table, but he believes that all the elements are all the same. All the elements, I shouldn't say that. So Dalton believes that all the elements in a family are equal. Now, what this means is the following. So if you have your periodic table, right, every single one of those squares represents a family, right? So for example, let's focus on the element here. What is this one? So let's say they are focusing on zinc, just to say one, right? So if you're focusing on zinc, there are different, in nature you look, right, and you find a piece of zinc, another piece of zinc, another piece of zinc, but Dalton believes that every single one of those zincs, yes, they do contain 30 protons, because if you look in your periodic table, zinc has 30 protons, right? But you also see that the mass for zinc is 65.39, right? So what does this mean? Mass is 65.39 AMUs, atomic mass unit. Well, you know that the mass, okay, the way we calculate it, is equal to number of neutrons and number of protons. Now, this is an integer, this is an integer. When you add integers, you have an integer. So how do we get to 65.39? And this is the thing that Dalton does not know. So he doesn't know that there is a zinc slightly heavier than 65. So for example, 66. There's another zinc that maybe has a weight of 67. There's another zinc that maybe has the weight of 64. I'm just saying numbers. Now when you average everything, maybe you reach the 65.39. So every single one of those elements, though all of them contain 30 as protons, but if you have a 66, right, as a mass, and you know that this is the neutrons plus the 30 protons, so for this element here, you will have an N number of neutrons equal to 36. For this one instead, you might have a number of neutrons equal to 37. Because it becomes 67 equal to N plus 30, so that would be a 37. For this one instead, the number of neutrons would be 64 minus 30. So for this one, it would be a 34. Now, every single one of those elements share the same number of protons. So every single one of those zincs contains 30 protons. But this one contains 36 neutrons, 37 neutrons, 34 neutrons. So because all of them are zincs, because they have 30 protons, they do have different numbers of neutrons. Therefore, those elements are considered isotopes. And Dalton has no idea, because he does not know that there are neutrons, right? He doesn't know that there are isotopes either. So to him, yes, every single one of those elements is identical, right? But it's not true. So this is not true. It's not true that they are indivisible, because we know that you can divide them. You know that there are different number of electrons, a different number of protons, neutrons. He does not know that, and he doesn't know, therefore, that atoms of a given element are identical. He believes actually they are identical, but we know it's not true. So the choice C will be the one that is true in this case, not to be valid. So we disregard the part 2 and the part 3 of the statements. Then for the second question instead, you have this xenon here. You have 54 protons, right? Because the number here is number of protons, and this one is the mass. Now, if you're confused, well, which one is the mass? Well, mass, you know, contains protons and neutrons, so the mass has to be the bigger number. So this is the mass, this is the number of protons. Every single one of the xenon particles has to contain 54 protons. So basically, I do not necessarily need to say xenon. I can say the element with 54 protons, you know, has to be xenon. And then you look at your mass, which is the 132. So they want to know how many electrons, protons, and neutrons you have. Well, 54 again has to be the number of protons. So you will put 54 right here. Also, this one is a neutral element because I don't see any pluses or minuses sticking out there. So this one has to be neutral, so number of electrons have to be the same. 54 pluses, 54 minuses make a 0, right? That's the total charge of your element. Neutrons instead is going to be 132 minus 54, so it's going to be 78. So the choice D has to be your answer. And then for the part 3. For 3, they want to know which ones of those is a pair of isotopes. Well, we just went over it. And we decided that isotopes have different neutrons but same protons. So this one has a 6 and a 7. Not good. 6 and 6, yes, that's the same element. And then you have a 14 and 12. So this means that this one contains 8 protons. This one, 6 protons, 8 neutrons. This one contains 6 protons and 6 neutrons to get a 12. So B is going to be your pair of atoms that are isotopes of the same element. For the part number 4. So you have 3 elements that are naturally occurring, okay? And this is the abundance of it, and this is the mass of every single one of those isotopes. We want to know which one is the atomic mass. Basically, which one is the number that we would put in the periodic table if we were to come up with the average mass. So for this one, we have isotope. So we have the X, which has a mass of 221 stated, okay? The abundance is 74.22%, and the mass that comes down to B, okay, instead of just 221, which is the rounded one, in reality is 220.9, okay, AMUs. Then you have the other one, which is the X and has a 220 there, okay, which happens to be a 220 here also, 0.0, and the abundance for this one is going to be 12.78%. And then you have the other X, which is a 218, which has abundance of 13.00%, and this is 218.1 AMUs. Now, pay attention to those decimals, because you know you got to go for the right number of sig figs. And guys, do not disregard the number of significant figures. It is extremely important. You are 15 years old. Well, you're rounding to 15 years, okay? You're not saying how many days, how many months into the 15th year of your life you are, right? So I could say that you're 15 years and, for example, 2 months and 3 days. And so this will be, so this part here will be how many years, right? This one instead will be how many months you are into it. Other numbers, okay? So the next number may be how many hours, okay? And then how many minutes. and then how many seconds. In some scenarios it's important, in other scenarios it's really not. If I ask you how old you are, sometimes I just mean, okay, what's your age? I mean, how many years have you been alive? I don't care how many days, how many seconds, especially because by the time I finish asking, right, and you answered how many seconds, you lost that one already, right? So in this case, it could be valid if you answered in years, if you answered in days, months, hours, maybe minutes, definitely not seconds. Seconds is not an intelligent answer that anybody should give when asked, how old are you? So in this case, okay, I'm stopping basically at this rounding. So significant figures is a very important number, okay? So in this case, you all should know this is 4 sig figs, right, for every single one of those, and I'm maintaining the 4 sig figs everywhere. So as long as I am consistent, I'm fine with it, right? I should be happy. Okay, and let's keep going for how do we do that following calculation. So 74.22% of the mass, which is 220.9, and you're also adding the 12.78% of your mass, which is this, and you're also adding the 13.00% of your mass, which is 218.1, and you just do your thing. You put it in the calculator and you come up with 220.4, which is your answer B in your thing. As you notice, you can have numbers that are very close, right? For example, this one will not be the right answer because they are giving you one extra sig fig, and you do not have it. Because even though when you do your calculation, you might have a 0.42, the 2 here doesn't have any meaning because you don't have that much accuracy, right? Nowhere you have 5 sig figs. So if you got 4 throughout your weighing, for example, in your calculation of your abundance, how in the world can you have a higher accuracy than the one you have come up with when you were actually doing your calculations, your measurements? So this number, though your calculator may give it to you, in real life has no meaning whatsoever. Okay, so watch out with those sig figs. Okay, they are very, very important. And then number 5, silver has 2 natural occurring isotopes. Okay, so in this case, you got the mass and you got the other mass. They are rounding to 107, okay, but has this isotope and this isotope. So the average mass they are stating is going to be 107 point blah blah blah. Okay, so how much is this percentage? How much is this abundance and how much is this abundance? Okay, so for example, this is 107.9, let's say, if we round. Okay, so it is in between 107 and 109. Okay, so which one is the higher percentage? And again, you got to do your calculation and you see which one is the number. So if you keep your packet in front of you, you may follow better the calculation that I am about to do. So they are saying that this is your mass, the average one that they are giving you, right? So this mass here, okay, 107.8682. So that's the one I'm talking about. And this one comes from the mass 106.90. This is a 90. 509, okay, which has a certain percentage, okay, and then you have the other one, 108, we said, 0.9047, okay, which has the other instead percentage. So if this is 20%, this one is going to be 100 minus 20. If this is X, this is 100 minus X percent, right? So because this is percent, let me write it as percent. Okay, and then you do your math and you find that X, okay, is a 51.835%. Okay, but and you have 2, 4, 5 sigfigs, okay? So percent, this means 0.51835, right? 835. So C is your answer. Okay. Then number 6. For number 6, we have which one of the following conclusion can be drawn from J.J. Thomson plum pudding? And you remember, what does J.J. Thomson say? Well, according to him, which is the one that comes after Dalton, right after Dalton, he is the one that knows the atoms contain electrons. So that would be the right one, okay? Because the other one says practically all the mass is contained in a nucleus. No, that's Rutherford. Atoms contain protons, neutrons, and electrons. Well, until 1933, nobody knew about neutrons because neutrons are due to Chadwick. And then atoms have a positively charged nucleus. Again, it's not true. Electron cloud. This is really Heisenberg. And no two electrons in one atom can have the same four number of. This is the Pauli exclusion principle, so it's not it. So A has to be the answer in this case. 7 to 9. You have those choices to take care of. So for number 7, explained. So who explained, which person, which scientist, or which model explained the spectral lines by postulating that electrons were only able to exist in discrete orbits of differing energies around the atom? And that will be Bohr. Then number 8 describes the location of electron series of possible quantum states. So those are the quantum numbers. Quantum states are allowed, and you have the quantum numbers right there. Then for number 9, caused by electrons emitting energy as they transition from one specific orbit to another. And this is the spectral lines. And then 10, you have which of the following is correct, is a correct interpretation of the results of Rutherford's experiment, the gold foil experiment. Well, atoms have equal number of positive and negative charges. That's not the purpose of the experiment. Electrons are arranged in shells. This is not the purpose of the gold foil experiment. Neutrons, it has no idea about neutrons, no idea about neutrons. Positive charge is concentrated in a small region. Yes, that's the one. Then 11. The energy of a photon of light is blank proportional to its frequency and blank proportional to the wavelength. So they are talking about energy, right? So for the energy, okay, let's go to a new page. So for the energy, we know the equation, okay, or you should know the equation. So the equation says energy equal to the h, which is the Planck's constant, times the frequency, okay? So h, remember, because later on I think there are going to be calculations, so this is the Planck's constant, 6.626 times 10 to the negative 34, and this is joules, this is second, this is hertz, right? Hertz is 1 over second, so the unit are joules seconds. And then nu, okay, is defined as frequency, okay, and the unit is hertz, which is the same as 1 over second, and E instead is the energy, okay, and the unit is J for joules, okay. So the energy is also, one more thing, that wavelength, okay, is defined as C over nu, and C is the speed of light, you know that much also, right? Speed of light, which is 3 times 10 to the 8th meters per second, okay, this is how fast the light, how fast the light travels, or how many meters in 1 second the light travels. And so from here you see that the energy is is directly proportional, because this is twice, this one becomes twice, right? This is just a constant. So 2 of this means 2 of that. So it's directly proportional to the frequency, and is inversely proportional to the wavelength, because I can write this as well, right? So, where is it? So is 11 is directly to the frequency and inversely to the wavelength. So D is your answer. 12. What is the wavelength? Okay, in nanometers, if you have this much frequency. So, like we said, you have the frequency, you got to calculate the wavelength. So you will use this equation right here, right? So 3 times 10 to the 8th divided by the frequency that I have, 3.22 10 to the 14th. Second to the minus 1 is 1 over second. I hope you know that. So the calculation of this is going to be your wavelength. Okay, and so you're calculating the wavelength as 3 times 10 to the 8th, because this is meters per second, divided by the other number that is 3.22 times 10 to the 14th, 1 over second. Okay, so meters over second, 1 over second, simplify. So you have the meters right there. So you do your calculation and you have the number as 9.32 times 10 to the negative 7. And this is meters. Okay, or you can say, because they want it in nanometers, so you can say 932 nanometers. So A is your answer, 932. Okay. Number 13, the energy of a photon that has a wavelength of 9 meters is how many joules? So you have a wavelength, okay, there is 9 meters. You're looking for energy, okay, so you're looking for energy and you know, so you got to use this equation here, right? So you have the 6.626 times 10 to the negative 34 times the 3 times 10 to the 8th meter per second divided by the wavelength, which is 9 meters, so that's already meters, so you can do that. And your number is going to be 2.2 times 10 to the negative 26 meters. And A is your answer. Okay. Then for periodic table, okay. So which pair of elements would you expect to exhibit the greatest similarity in their physical and chemical properties? Well, they better be two elements that are written one under the other. So A is your answer, because if you look at your periodic table, oxygen and sulfur are one under the other. So you have oxygen at level 2 and then sulfur at level 3, and both of them are in the 6A period. So 15, an element that appears in the lower left corner of your periodic table. So pay attention to your periodic table. An element that appears in the lower left corner of your periodic table. So this is your periodic table. The lower left corner has to be this one, right? So just do not memorize, understand everything you say, everything you do. So if this is your periodic table, you know that those are what? Those are noble gases. So if those are gases, definitely they are not metals, right? Also, those are transition metal. So those are stuff that make you go from here to the noble gases, right? So if this is transition metal, that means you're transitioning right throughout those metals until you reach the gases. So this one has to be the metal, right? So those elements, right? An element that appears in the lower left corner has to be a metal. So B will be your answer. 16. 16, the elements in group 1, 17, and 18 are called what? So 1 is this one. And again, remember that hydrogen doesn't really belong anywhere because this is the metal ones, metal cones. Hydrogen, I bet, is not metal, right? It's just a gas, right? Helium also. So remember, pay attention to hydrogen and helium. They are just two lost souls, okay? They don't really know where to belong. But nevertheless, according to the way we want to call those columns, okay? So one has to be the metals, right? And this is not earth, this is just the alkali. This is the earth. Number 2 is earth metal. So the 1 is alkali metal, 17 are those halogens, and 18 are those noble gases, right? So alkali, and then you have halogens and noble gases. So C is your answer. 17. Which one of the following is most likely to lose electrons when forming ions? Well, again, pay attention to your periodic table. Those are your elements, right? They have a +1, +2, because remember that every element, okay, on this periodic table wants to be noble. This is your nobility, okay? So everybody wants to get here. So for lithium, okay, how much does he have to travel until he get here? He has two choices. Either he keeps on going, right, from 1 electron that he has over here of valence, he needs to have all the way to 8, right? So he needs to gain 7 electrons, or he just can go 1 back, okay, and become helium. So just because every single element is lazy, right, lithium would like to lose 1 electrons rather than gain 7, okay? So the question was, which one will be more willing to lose electrons? Well, those that want to lose electrons are those on this side, right? They want to lose, this one wants to lose 1, this one wants to lose 2, this one 3. This is not sure, it depends, right? But this one wants to gain, this one doesn't want to lose 5, will rather gain 3 until it becomes noble, right? So with that in mind, okay, which one out of those would like to lose? Well, fluorine, right, needs only 1 extra, so doesn't want to lose it. Phosphorus doesn't want to lose it, right? So let's go over those. Fluorine is this one, wants to gain 1. Phosphorus wants to gain 3. Then you have rhodium. This one, okay, is right here. This one still is a metal, right? This one still would like to lose electrons because they do. We will go through this later in our course, okay? And then you have S and N. So pay attention to the sulfur. Sulfur needs only 2. Nitrogen needs only 3. So out of lot, we can say that this one is the only one that really wants to lose it. In reality, yeah, metals want to lose, okay? Just as a rule of thumb, metal wants to lose, and those elements instead they want to gain it. Okay, so C is your answer. And then 18. 18, when a metal and non-metal react, the blank tends to lose electrons and the blank tends to gain electrons. And we just said metal loses it, right? And non-metal gains it. So C is your answer. 19. Blank typically form ions with the 2+ charges, and this is the second line, right? The second column, I should say. So the alkali earth are the ones that usually form the +2 charges, okay? So A, alkali earth metal. Now let's go for chemical names and formula. So number 20. What is the ratio of hydrogen to oxygen atoms in the mineral chalcocyanide? And this is the formula for it, okay? So this is iron, that's your phosphate, this is your hydroxide, and you have 12 waters, okay? So if you're thinking about atoms, all of those are molecules, or you have atoms according to what you're looking at, okay? So you have 4 atoms of iron, 3 molecules of PO4, which is your phosphate, and then you have 3 molecules of your hydroxide, and then you have 12 molecules of water. Or you can say how many moles are those, that's what I mean. But since they are talking about atoms, okay, and you're looking at those those elements, then those to you are atoms and not moles. Okay, but really doesn't change much. So you are looking at the ratio between your hydrogen and the oxygen. So count how many hydrogens you have. So hydrogens are only here, which is 3, right? And here, which is your 24. Okay, so you have a 27, okay, atoms of hydrogen. Now count how many oxygens you have. Oxygens you have 3 times 4 is 12 here, plus 3 here, so you have a 15, plus 12 here, 15 plus 12 is 27, so you have a 27 hydrogens and 27 oxygen, which basically means 27 to 27, so is the ratio 1 to 1. So D is your answer. 21. Which of the following compound would you expect to be ionic? Well, ionic, is between cations and anions, I should say between metal and non-metal, okay? So sulfur and fluorine, they are too close, right, to be ionic. Then water, well, water is your molecule, right? H2O2, the hydrogen peroxide, is also a molecule. The ammonia is also a molecule. Basically, every element for which you can draw the Lewis structure is not ionic, okay? So the only ionic one is going to be the calcium, because it's the one that you know is 2 plus and 2 minus. You got to balance those charges. This is metal, this is not metal. So there are a lot of things that you can think of to be able to answer that. The ionic one is calcium oxide. And then 22. 22, the charge of an iron ion, okay, in the salt, okay, for this formula here, which is your, remember how you calculate this one, right? So you got to balance those charges because iron is metal. I hope you remember that, right? And oxygen is not metal. So this means the iron has to have a charge of 3, right? While oxygen has a charge of 2. Remember those oxidation states. So iron plus 3 is the charge. Okay, so C is your answer. And then 23. 23, what is the formula of the compound formed between strontium ions and nitrogen ions? The formula between strontium and nitrogen. So how do you do that? So strontium is right here, okay, which is your plus 2. What was the other one? Strontium and nitrogen. Nitrogen is right here, which is your negative 3, okay? So you have a plus 2 or you have a negative 3. So do you remember how to calculate those stuff? What was it? Strontium, right? It has a charge of plus 2. And nitrogen has a charge of negative 3. You got to balance those charges. So the common denominator, there are a ton of different ways that you can think around in such a way that you have the right formula. But you got to have the same number of charges. So to balance those charges, you got to have 3 of those and 2 of those in such a way that charge plus here is plus 6, and this side is negative 6, and your total compound has a charge of 0. So you will write it as strontium with a 3, nitrogen with a 2, and that's your formula, okay? So strontium nitride is the answer, which is, what did we say? This one. So B is your answer. Then 24, which species below is the nitride ion? Well, it's this one. We just saw it before, right? Because it's the nitrogen that you used up there. So E is your answer. And then 25, which one of the following compound is chromium 3 oxide? Remember, for chromium, right? Chromium is a transition metal. You do not know the charge of chromium because it could be the different values, right? They are stating there is a chromium 3. So basically, pay attention to this one. Those are all the oxidation states that chromium can have. Okay, I want to make it bigger. Okay, so can be a 3, can be a 2, can be a 6. Okay, so could be any of those, and you don't know until they say which one they are using. So, and they are so nice, they have to say chromium 3 oxide. Chromium 3 oxide, so this is your chromium 3 because they said so. Oxide is this. Usually, I mean, not just usually, we do not show those charges, okay? So because you got to balance those, so you need a 6 here and you need a 6 on this side, right? So how do you make this one 6? Well, you got to add 2, right? So 2 times 3 is 6, and then you have a 2 times 3 is negative 6, for a total of 0, which is what you want. So this is your formula, okay? With nothing sticking out to mean that you are dealing with chromium 3 oxide. That's it. So, what was it? This, okay, is your choice. 25. The choice A is your answer. And then 26. What is the correct formula for ammonium sulfide? Again, so you take your ammonium, okay, so this is ammonium, okay, with a charge of -1. Sulfide, okay, sulfur is under the oxygen, so this is a -2. Okay, so how do you do this? Well, to balance it, okay, this one has only 1 charge, this one has 2, so I need 2 of those, right? So that would be your formula. So NH4, you need the parentheses there with the 2 and then S. Okay, so C is your answer. And then 27, which formula name pair is incorrect? Okay, so this is iron sulfate, charge 2 and 2, perfect. This is iron sulfite, okay? This is 2, this is iron 3 because they said so, yeah, that's fine. And then iron sulfide, 2 and 2 because they said so, that's fine. Iron 2 sulfide, this is also fine. Iron 3 sulfide, well, I see a persulfate, so it's not right. So 27E is your answer. 28. 28. Formula of the compound formed between aluminum ions and phosphate ions is. So aluminum ions means aluminum plus 3. Phosphate, okay, is -3, so 3 minus, whatever. So you just need both of them have a charge of 3. So this is right, but it's also wrong at the same time because your formulas have to have the smallest denominator possible, basically, right? So if you divide everything by 3, nothing changes, okay? So your answer is B rather than A, okay? Because this is not a skeleton structure, this is the skeleton one, okay? There's no reason to go for 3 and 3 if you have the same balance for 1 and 1. And then 29, barium reacts with the polyatomic ion to form a compound with the general formula barium and whatever ide you have there. Okay, so what would be most likely the formula for this if you have a sodium and the polyatomic ion X again? Well, what you would need to do is that you know the barium has to have a charge of 2, right? And the X has to have a charge of -3. So if you have this kind of formula, let me write it in such a way that you see what I mean. Okay, so if you have barium, okay, and you have, what was it? Barium has a 3, okay, and X as a 2, okay. So, and you know that barium belongs in the +2. How do you know that? Well, you go here and you see the barium is down there. Barium is here a +2, okay, whereas the sodium has a plus, right here has a +1, okay. So how would you do for this one? So in this case, you know that this is a 6 because this is state, okay. I mean, this is a statement. You know that this is 3 and you know that this is a +2 because you know what barium is. So here you have a +6. This thing is neutral, so here on this side you got to have a -6, which means you got to have a -3 as a charge up there. So in such a way that your total charge is 0. Now on this side you want to put together the sodium, which has a +1, and the X, which has a -3. How do you balance this? Well, you need 3 of those, obviously, and only 1 of those, right? So sodium with a 3 and X is your answer. Up here. So sodium with a 3 and X. So D is your answer. Okay? And then 30. Which one of the following is true concerning the simplest unit of? Then they say one positive ion and two negative ions. True, one positive ion and two negative ions. The concept. So molar mass of, well, this is super easy, right? So those kind of calculations are easy because you have, okay, how much does this one weigh? Well, what are you putting on the scale, right? So I would say just draw your ammonium phosphate, okay? So your ammonium phosphate looks like, so you have your ammonium, okay? And this is your ammonium, this is your phosphate, okay? This is a charge of 1, this is 3, so you need 3 of those, and that's exactly what it was anyway, okay? So when you put this on the scale, so first of all, how would you draw it, okay? Because it's all about how you draw stuff, okay? So you have your ammonium, okay? What does it mean that you have this? So you have your ammonium, okay, NH4, but you have 3 of those, right? So in this package here, okay, I see ammonium 3 times. So ammonium, 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 okay, NH4, NH4, and NH4. And then I have 1 phosphate. Okay, so this is what this package looks like. I can even break this one down, right? So I have 3 of those ammonium and I have 1 PO4. Okay, so this is the box again. And now let's count everything. How many hydrogens, nitrogens am I seeing? I've seen 1, 2, 3. So I have 3 nitrogens. How many H's I have? I have 4 and 4 and 4. So I have 12 of those hydrogens. I have 1 of those P's, of those phosphorus, and I have 4 of those oxygens. Now, if this is the scale, right, and I have to put this one, what I would put here? Well, I will add 3 nitrogens, and I will add on top also 12 hydrogens, and I will keep on stacking here 1 of the phosphorus, and I will also keep on adding, right, 4 of those oxygens. So what am I reading here? So at the end, I'm reading 149. Okay, so that would be my answer. 149.09 is your answer. Okay, so C. And then 32. 1 mole of blank contains the largest number of atoms. Well, and you gotta count, right? So this one, how many atoms are making this one element? Well, 8 of this one, 18 of this one, and then 2. So how many atoms in all I have? I have 2, I have 3, which is 5, I have 12, which is 17. And for this one, I have 3, I have 1, I have 4, so I have 5 and 3, 8, and this one is just a 2. So B is the largest number of atoms. 33. 33, you have a 30.5 gram sample of glucose, okay? So how many moles of glucose are there in 30.5 grams? So, let's add those, okay? 30.5 grams of glucose, okay? How much one weighs, right? So for this one, you have 6 of those carbons, and you have 12 of those hydrogens, and you have 6 of those oxygens, okay, for a total of 180 grams per mole. So this means that 1 mole has a weight of 180. So you only have 30 grams, 30.5 grams. So first of all, do you have more or less than 1 mole? Remember, 1 mole is 180. You have 30. So you almost have, what is 1/6 of it? Right? So anyway, so you got to have a number that is small. Okay? So how do you do that? So you start with what you have. You have 30.5 grams of glucose, right? And then you know that you have 180 grams in 1 mole. That's what you also know, okay? And you put it that way just because, right, you got to cancel out those units. So you do 30 divided by 180, and you have a 0.169 moles, which is your answer. Okay, B is your answer. 34. How many moles of oxygens do you have in 1.08 moles of calcium nitrate? So, first of all, you have calcium nitrate. And you need 2 here because you have a charge of +2 here and -1 there. Okay, so this is your calcium nitrate. Then, oh, and they said it anyway. So 1.08 moles of this is what you got. Okay, now they want to know how many moles of oxygens you have. Okay, so you have to shrink it down to oxygens. So, because this is moles, okay, if you have 1 mole of calcium nitrate, okay, you will have 6 moles, okay, of oxygens. True? Now, instead of 1, you have a 1.08. Okay, so if you have 1.08, okay, and you have some moles of calcium nitrate. Okay, so if you have 1, okay, if you have 1 mole of calcium nitrate, you will have 6 moles of oxygen. If instead you have 1.08 moles of calcium nitrate, how many moles of oxygen would you have? So it makes sense that you're multiplying by 6 anyway, right? So your number is going to be 6 times as much, which is, so this is 34, which is 6.48. So C is your answer. 35. How many grams of calcium nitrate, still calcium nitrate, contains 24 grams of oxygen atoms? So if you want to have 24 grams of oxygen, how much calcium nitrate you have, considering the oxygen comes inside the calcium nitrate as that, right? So let's see how we can figure it out, how we can figure this one out. So you have 24 grams, you want, I should say, 24 grams of oxygens, okay? So you want this one, how many grams of this you want? So 24 grams of oxygens, okay, means that how many moles you have? Well, you know that in 1 mole of oxygen is 16 grams, right? So now you know how many moles of oxygens you have. So 24 divided by 16 is your answer. But once you have those moles of oxygen, because those grams are going away, right? You remember we just said that for every mole of calcium nitrate, you need 6 moles of oxygens, right? So I can say again that for 6 moles of oxygen, I need 1 mole of calcium nitrate, right? So now I don't care about the moles of calcium nitrate, of oxygen anymore. Now my number is telling me how many moles of calcium nitrate I have. And they are asking for grams. So I know that 1 mole of calcium nitrate is a weight of, well, whatever is there, right? So you do your calculation, and so calcium nitrate is 164.1 grams. Okay, and at this point you just multiply and divide, and you have your total number, okay, which is 41.1 grams, which is E. Okay, then 36. 36, you have how many molecules of methane are in 48.2 grams of this compound. So how many molecules? So when you read those kind of stuff, pay attention and restate. Are they asking for molecules? Are they asking for moles? Because it's super easy to go from grams to moles, but usually, the main mistake that might happen is that you think about moles, not molecules, so you forget to go through the Avogadro number anyway. So 48.2 grams of this compound. Let's see how we can do that. 8.2 grams of methane. Okay, so remember methane. Actually, you don't have to remember anything. It's just carbon is 12. If you don't remember those numbers, just look at your periodic table. Plus 4, so you have a 16 grams per mole. Okay, is the molar mass for methane. So they are asking for 48.2. 48.2. So how many molecules do you need? So you're going for 48.2 grams, okay, of the entire methane. Okay, so 1 mole of methane, okay, is 16 grams because we just said so. Okay, so now the number that you have, okay, so this is the methane, so it's not this anymore. Now you have moles of methane. So again, they are asking for molecules of methane. So in 1 mole of methane, okay, you know that there are 6.022 10 to the 23rd molecules. Okay, so at this point you're basically done. And your number is 1.81 times 10 to the 24th molecules of methane. So for number 37 instead, what number of moles of O2 is needed to produce 14.2 grams of tetraphosphate? So 14.2 grams of tetraphosphorus decaoxide. Okay, and they also say that the reaction is a synthesis one, which means I have phosphorus and I have O2 that react together to form the compound. Okay, and they also say that 1 mole of this is produced for every 5 moles of O2, right? 1 mole of this is produced for every 5 moles of oxygen. Now, if I need to balance this, obviously that means I need 4 moles of P also, right? So let's go backward, basically, right? So if I have 14.2 grams of this, okay, how many moles I have? Because if I have 1, I need 5 moles of O2. So, because they say, okay, how many moles of O2, and they are giving us the molecular weight of the compound, right? So this is 284 grams per 1 mole, okay, of P4O10. Okay, so you do your division and you have a 0.05 moles, okay, of P4O10. Okay, so now you see that the reaction is making 0.05, right, P4O10. So if this is true, how much of O2 I need and how much of phosphorus I need, right? So here I have a 4 for phosphorus. Here instead I have 4 times, right, 0.05 of phosphorus. And here instead, right, I have 5 times 0.05, which means I need 0.25 moles of O2. So the answer is D. And then 38. Which of the following gas samples contains the greatest mass of gas molecules? Well, because of Avogadro, you know that every 1 liter, so every mole of the atom, every mole of gases at STP, closed, I should say, in a volume of 22.4 liters. So if this is 1 liter, you can think backward, right? So the same percentage of moles applies to everyone, right? So which one contains the greatest mass? The xenon. 39. Molarity of an aqueous solution contains 75.3 grams of glucose in 35.5 milliliters of solution. So you remember the molarity is the same as moles of solute over liters of solution. Okay, so according to the formula, then you have 75.3 grams of glucose, 75.3 grams of glucose, okay, and you got to convert to moles. So 1 mole, because that's what they say, moles, right? So 1 mole of glucose has a mass of, we calculated before, it was 180 grams, right? So this one will give us a number of moles of 0.418. Okay, so those are the moles. And then they say in 35.5 milliliters, right? So this is 0.418 divided by, what did I just say? 35.5. But this is milliliters, I need liters. Okay, and now I'm done. So by doing the ratio here, I have 11.8, okay, as molarity. So 11.8, so E is your answer. And then 40, how many milliliters of this solution, this molar solution, contain 25 grams of sodium hydroxide? So I got the molarity, I want to know the volume if I have grams, which I can use easily to go to moles. So for this one, I have 0.123 molarity, right? And sodium hydroxide, this is 25.0 grams, okay? So 25.0 grams of sodium hydroxide, which has a mass of 40 grams per mole. That's what it says up here, right? 40 grams per mole. So now I also know how many moles I have because I'm dividing those two numbers, right? And then, well, whatever this number is, right? So I have the number is 25 divided by 40. So those are the moles divided by the volume. Okay, so I got to solve for volume. So volume is going to be 25 divided by 40, whatever that is, right? Divided by 0.123. Okay, and is 5.08 liters of 5080 milliliters. So C is your answer. Okay. Then 41. What is the total concentration of ions if you have a molarity of them? So those are moles. So when you break the sodium carbonate, so you got sodium carbonate. Okay. When you break this one in water, you have 2 sodium and you have 1 carbonate. Right? Now, if you have, how much was it? If you have this solution which has a 0.036, so 0.036 moles of this, okay, per liter. This one, right, gives me a twice 0.036. And this one gives me a 0.036, okay, and those are moles of ions. So if I add them, that's horrible. So this means twice, and 1 is 3 times 0.036. So I have a 0.108 moles of ions. So your answer is B.